reading cap values. So if the capacitor, the little flat ceramic disc is with a capacitor, and let's say you see a number on here that is 104. The one that was shown in the textbook was, I think it was a 105. Let's see what the textbook shows. Yeah, that was a 105. We're going to put in 04 in contrast to what you have in your textbook. So when you see these three numbers, it's very easy. There's a method by which you are able to determine the capacitor value. And the first digit is your first digit of the value. So first number equals first digit of cap value. Second number equals second digit of cap value. Third number equals number of zeros. Number of zeros, and then number of zeros before PF, which is picofarads. And as a reminder, pico is 10⁻12, okay? So let me show you how we interpret this guy. If you see a marking and it shows 104, what is my first digit? My first digit is a 1. If my first number is a 1, it represents the first digit of my cap value. So this would be interpreted this way, as a 1. And then the second number is a 0. It represents my second digit of the cap value, so it's going to be this guy here. And then the third number represents what? The third number represents number of zeros. And how many zeros is represented by the third number? 4. So I'm going to write down 4 zeros. 1, 2, 3, 4. Now I've got 4 zeros. And all of this is in what units? All of this is in units of picofarads. So I'm going to write picofarads over here. And so what this means is we happen to have, guess what? 100,000 times 10 to the -12 farads. Wow. Well, we know that we don't key anything into our calculator or write down any answers unless they are proper engineering notation. And this has got 6 digits here, so this is certainly not proper engineering notation. Try this right now. In your calculator, key in 100,000, so just on your calculator, key in 100,000, EXP, change sign, 12, and then hit the equal symbol, and see what your calculator displays. Calculator should display. And the question goes to, let's see, Pauline, what do you got?
I got 100 nano.
Yes, you would have received 100 EXP -9, and you know -9 is written as 100 nanofarads, okay? Now, capacitors are very interesting. What we have here, this value that you've just calculated is proper engineering notation. We've learned this as being such since the second week that we were together. Capacitors, however, do not conform to proper engineering notation. Capacitors, however, are standards at very specific units. So standard cap units will be equal to farad, will be equal to microfarad, and will be equal to picofarad. Those are the standard units. In capacitors, we would not write our answer in nanofarads or gigafarads or millifarads. These are the standard values: farads, microfarads, and picofarads. So what happens is this is actually equal to 0.1 microfarads. Okay, they are the same value. 1.1 microfarads is the same as 100 nano. So I want to point out the distinction to you in case you happen to see this. You'll say, wow, in the literature, either put down an answer, or in the literature, some book printed a decimal point, some kind of microfarads, or a decimal point, some kind of picofarads, something. How come they're not using proper engineering notation? Is because the world, it's not just the US, but the entire world standardizes capacitor values at these increments, all right? But for our calculations, we'll just go ahead and use the 100 nanofarads. That's perfectly fine because it conforms to what we've learned since the first, second weeks that we were together. So is everybody okay with the manner of how we read cap values? Whatever numbers are shown here, first number represents first digit, second number represents second digit, third number represents what? The number of zeros before what? Before writing down lowercase p, capital F, which stands for what? Picofarads. And picofarads is 10 to the power of negative 12. So this 104 becomes a 10, followed by 4 zeros, followed by picofarad. And then you put this into your calculator as 100,000 10 exponent negative 12, and let your calculator spit out the appropriate engineering as being 100 exponent negative 9, which you would understand to be 100 nanofarads. Are we okay with this so far? Now, let's go back and take a look at the example that was shown in the book. The example that's shown in the book was a number 105. So a number 105 cap. How do we play with this particular guy? Okay, so what is the first number? What is the second number? And the third number represent? So first number represents first digit. Second number represents second digit. Third number represents number of zeros before we write down picofarads. Okay, so if we go to interpret this particular guy, we have a 1 followed by a 0. And then we're going to write down number of zeros. So the number of zeros in this case is 5. So we're going to write down 1, 2, 3, 4, 5 zeros. Then followed by what? Followed by picofarads. So by looking at this number, have we properly interpreted as this so far? Hopefully so. The pico is 10 exponent negative 12. So if you go to punch this into your calculator, this should work out to be 1 microfarad, yes? Gabriel?
Yes.
Yes.
Yeah, it does.
Yeah?
Yes.
Okay, and this should give you 1 microfarad. All right. So now I've got something more interesting for you to do. Suppose you have a cap value that's this guy right here. Cap value is going to be a number 474. 4. Go ahead and interpret a 474, and I will call upon names in a moment. First number, second number, third number is first digit, second number is second digit, third number is number of zeros before we have picofarads. So, Mr. Lau, Wenbin, help us out with this. How do I start writing my capacitor value? How do I interpret this as being some number of farads? What's the first thing I do? Can you give me the first digit, sir?
First digits. Oh, I can't
Turn
see.
off your mic.
That's more. 474.
For this guy right here.
474, one digit.
Wenbin?
Yep. You hear me?
Yeah, I'm looking for the first digit. What is my first
Yeah,
digit?
474. Is that it?
Well, 474 is the number that's printed on the capacitor. Your job is to interpret that based on everything we've done here in the past 3 examples.
Interpret. I can do the answer.
Andrew, do you have my first digit?
Yes, I do.
What's my first digit?
4.
First digit is a 4. First number represents first digit. It's a 4. My second number, let's take a look. Christian, what do you have?
7.
7. Okay, so Wenbin, coming back to you. How many zeros am I going to write? The third digit tells me how many zeros. How many zeros am I going to write?
1.
No, sir. What's it say here?
4. Yeah,
This-
4.
4 and a 7. So 4 and a 7. This 4 tells you 4 zeros. 1, 2, 3, 4. Now, Kyle, what do I have to write down after these 4 zeros?
The picofarads?
So I write down
I thought
lowercase
smart.
p, capital F, yes?
Yes.
Picofarad is what power of 10, Rebecca?
Negative 12.
Negative 12. So if you key this into your calculator, what is the value that your calculator spits out? That question goes to Andrew. Andrew?
It is 470 .00, I guess, but it's to the -9.
And what engineering prefix -9?
-9 is a nano.
Yeah, exactly. So your calculator did show 10 -9 farads, which we will write down as lowercase n, capital F. So are we okay with how to interpret a capacitor value based on some code that is printed on the outside of the capacitor? Everybody
Yes.
good with this? Based on this example that we started with at a 104, based on this as a 105, based on this as a 474. So everybody okay with that? So far, so good? Okay. Now, most capacitors are not a mystery. Most capacitors that you're likely to encounter, like these, electrolytics. Here's an electrolytic capacitor, and here's another electrolytic capacitor. And so on the electrolytic capacitors, it turns out that they happen to have a printed value right on the body of the capacitor. And it's, let's see if I can hold it steady so that the camera can focus on this. Let's see, get some light on this. Can we have any kind of light on this and then try to focus and rotate it and you can almost make out, I'll try the focus again. Aha. Can you see a 100 microfarad written on there? And then it has 25 volts. Okay. I'm surprised. Wow.
Yeah.
There we go. Pretty good. Pretty good. Anyway, let me hold it up to the light a little differently. Do a focus again. Turn off your mics, please. And right there, if I catch the light just right. Anyway, it's a little, yeah, you have 100 microfarads. So it's printed on the body of the electrolytics because the electrolytics are large enough. And then they're also, what else is also printed on the electrolytics is the white band that shows the negative side of the capacitor. So there's that white stripe on the body of the capacitor, and it happens to be attached to this wire, which is the negative wire, and then the longer wire is the positive wire. So that's how you, the electrolytics are large enough that there's no mystery in terms of how to determine what their value is. So, but the ceramic ones, the disc ones that I showed earlier do need to be interpreted. All right, so now let's move on.